Hello again. This is the course of data structure and algorithms, and I would like to teach you one concept about array. And the title for this chapter is Array-Based Sequence. And the slides is taken from the book that I recommend to you, which is about the data structures and algorithms in Python, written by Goodrich, Tamasya, and Goldwasser. So I will start the explanation with the agenda. The agenda of this slide will be about the Python sequence classes and then some type of operations in especially the operations in array and growable array. So let's start with the Python sequence classes. What is the Python sequence classes? You know already in Python they have the built-in types like list, tuple, str. Okay, so do you know what is the difference in list, tuple, and str? Yeah, you know that list is something related with this list, yeah, and you can change. It is immutable, but tuple is immutable, so you cannot change the data. For the str is the string, and then you can make it as a list. You can make it as also a top tuple. Okay, maybe I will try to give you an example. Okay, you still remember if it is a list, then you can just make any data type. Okay, so the integer, float, string can be in one list. And if you have a tuple, so it is a different representation. When you have a list, you should use the square bracket, but if you use the parenthesis like the common bracket, it is for tuple. Okay, and if you have this tuple, yeah, it's the same result, but you already learned in the chapter 1 that the tuple is not changeable, so you cannot change the value, but you can change the value on the list. In the string format, you can see that if I have the triangle, it is a string, and you can create a list. When you create a list like this one, then the character will be separated, and each of the character will be the element of a list. Okay? And based on this, we can get the information for each character, and we can say that this is the index 0, index 1, and so on. So it is a sequence. Okay? In different way of thinking, you can also have a list of string elements. Let's say you have red, blue, and green. Okay? You already learned this in chapter 1. So let's get back to the concept of array. So if we are dealing with the array, let's say this is a list or tuple or string, you will deal with, for example, we have the variable a, and you will use the square bracket I. So I representing the index. Okay? If you are using the array, so you have the index, and Python will start the index with 0. Some programming language will start with 1, but Python starts the index with 0. Let's say I have the index 0, okay, for the first time, index 1, index 2, and so on. I have index I, which is somewhere in the middle, and let's say I have n. Okay, so n representing the final or the size of the array. Okay, if in Java, for example, in Java programming language, you need to define the size of the array in advance. If you are using the array list, then you can have a free size. It means whenever you put more elements, then the size is resizable. But if you use the uh, common array, you need to define the size first. In Python, when you use list tuple, the size also resizable. So when you add some more elements, then you can add the size automatically. So if I give you the previous examples in the Python, you can see that the array of characters of object references. let's say if I have the primitive elements like character, so you can have the compact array. What is compact array? So like this one, I have S, A, M, P, L, E. So in the Python, I show you the example about triangle. So if it is about triangle, so it's related with the single element or the single character of the string. But we can also save or store references to objects. So for example, we have the first index, the index 0 is for the person Rin. The index 1 is for the person Joseph. The index 2 is for the person Janet. Okay. The index 3 for the person Jonas. So it represents one object. So one for one index represent one object. So the compact arrays is there is one library that supports this compact array. Okay, this compact array means we have the module to define a class, which is array, providing a compact storage for arrays of primitive data type. So if you are using a list, is yeah, is available from various data types. Yeah. But if you use the compact arrays, it is only for a particular primitive data type, and you can specify the data type, for example, integer. Okay. So for example, this one, I want to create a primes. So you know primes? Primes is a number that can be divided by 1 and the number itself. So you know this is like 2, 3, 5, 7, 11, 13, 17, 19. They are the primes. And I know that those numbers are integer. Okay, so I would like to use the compact arrays. It is from the class array, and I would like to define this element with the integer, and those are lists. Okay. So why we need to do this one? Because if we use this array class, there will be more operations in this array. Okay. In the array class, we can have many data types. So you know in Java, if you learn programming language, you can see the integer, you can see double. Okay. This is the data type in Python. So you can have a character P and the unsigned character big small big B. U is Unicode character. H is signed short integer. So this is the number of bytes, or we can say this is the size of the elements. Okay? And you can have the integer, and you can have, yeah, this one is the integer, and those are the float. Okay, so float means the number with the decimal. When the number is more real, then the size, or this is the bytes, is also greater. Okay? So when we deal with the array, we need to understand the kind of operations. Types of operation in array is something related with the insertion. When you have the array, you want to add something. You want to put more element. So let's say if I want to insert object O in the index I, okay, then I can do the operation add I, comma O. So I would like to put object O in the index I. Okay. So in an operation add I, comma O, we need to make room for the new element by shifting forward the n minus I elements, so which is I until an minus 1. We can have the worst case. If the I is 0, then it takes n time. Okay, let's see. If I want to put the an object here, what will we do? Next is we will move the elements from I until n. So we will shift 1. We will shift 1. This will shift 1, and this will be shift also 1, and this will be shift 1 time, because we want to add one object. So every object from starting index I until n will be shifted 1, and we put the object O in the index I. Okay, so this insertion will take on if I equals 0. Okay, so if the insertion is located here, what happened? Then every of this one will be shifted 1 until the n number. Okay, so the worst case is on. How about if we want to remove? Okay, removing the index I will be we just want to remove the index because we do not know what is the object inside. So we just say that, okay, remove index I. If we want to remove, it means we need to fill the hole left by the remove element by shifting backwards. And the elements that we want to shift, we want to delete will disappear, and the size also will be reduced. So we can have the formula n minus I minus 1, and the elements, okay, from elements a plus 1 until a n minus 1. So let's say if I want to delete the index I, so the same with the previous one, if I want to delete this index I, so we will remove or we will shift all the elements into 0. So like this one, if I want to delete the index I, so there is one object which is O. And if I want to remove this, so when I exclude this one, okay, what happened? This will be empty. Am I right? Okay. I don't want to put this as an empty. So the element which is I plus 1 will be shifted here. The element which is I plus 2 will be shifted to I minus 1. The element which is I plus 3 will be shifted to I minus 2, and so on. So the number of n will become n minus 1. Okay. So we have the new array like this one. Yeah. If the worst case scenario happens, then it will take on, because the worst case scenario, the I, which is 0, is the element that we want to remove. So the performance of this dynamic list, so we call it the implementation of the dynamic list, if you are dealing with the space, okay, the space used by the data structure is on. What does it mean by space? So you can have this one. So the space, yeah, of course, you know, the number of element is n, so we have the n times, or we have the n times. Okay, if we have if we are dealing with the indexing at the element at I takes 1. Okay, so it means we want to only give the index. Okay, if you want to add or remove, okay, you will need on. Yeah, you already know the time complexity. Yeah, that when we are dealing with the big O notation or the complexity, yeah, we just give the O with the function that we already learned. We have the O1, On, O log n, O n log n, and so on. Yeah. So in an add operation, when the array is full, instead of throwing an exception, we can replace the array with a larger one. So you already learned, if we want to insert array, then we will shift the elements according to the index that you want to insert it. But if you have the add operation, if the array is full, okay, if the array is full, then we need to have an idea to extend the array. So we are going to learn about the growable array. What is growable array? The growable array means we are dealing with the growth strategy. Let's say if I have the add operation, okay, and I have no index, what happened? Since I have no index, whenever I want to add one element, then it will be added in the end. Okay? It will be ended at the end of the array. So if you adding the index, or we are adding the object at the end, you need to know the size. Okay, so you need to know what is n. If you don't know the n, then when the array is full, yeah, you cannot do any other things. So if it is full, you need to replace the array with a larger one. So for example, when I want to add an object into the array, so I would like to give the t as the s as is the current sequence, and I want to check the length -1. If t is length -1, then let's say a is the new array of the size n, and then let's do the loop from 0 until n-1, and then let's put all the elements in the array S into the array A, which is the new array. And then let's move the array, which is already in the AI, into the S, which is the previous array. And then let's do the n equals to n plus 1. Oh, sorry. If it is 1, if this is the indentation. Okay. If the length is not greater, then you can do like this one. But if you have greater size, then you will add n plus 1, and then you will put the O or the object O into the index n minus 1. Okay. So this by using this one, actually you are thinking about the strategy to increase the size. Okay. So what is the increment strategy? So we can have the incremental strategy. It means we just increase the size by a constant. So you can increase the size by 1, or you can increase the size by 2, or you can increase the size by 5 times. So the C, the constant C, is not fixed. So you need to determine your idea, or maybe we can just add 1 for every time, 1 for every time. Or there will be another strategy, which is doubling strategy. Okay, double the size. If I know that I will increase 1, then I will add 1 first, and then again I'm adding 1 more, then it is double. So I just increase more time, like 4. If I want to add the third time, I think, oh, okay, because you already increase the elements 3 times, then I will make it double. So just make the array size 6, because I just plan for the worst case if you add more elements. Okay? So that's the doubling strategy. We want to double the size, double the size. So the comparison between the incremental strategy and the doubling strategy, we can do by analyzing the total time needed to perform a series of n add O operations. Okay, so the first in this way you will learn about this add O. So we are just giving a new array of size n, and then we need to check this add O operation. So we assume that we start with an empty stack, or this empty stack. So it's just empty list, okay, represented by an array of size 1. So we start with 1, yeah, the size of the array is 1, and then we can call amortized time. Okay, you need to understand this one later. I will talk about this one. The amortized time of an add operation, so it is the average time taken by an add over the series of operation. So we have Tn divided by n. So the Tn is the number of operation to add the object O in the series of n, and the n is the number of the size itself. Let's say I have the k, which is n divided by c. Okay, so c is the constant that you want to add. Okay, this is the incremental strategy. So if c equals to 1, okay, so if c equals to 1, then it means the k will be n divided by 1. Okay, then k will equal to n. if you want to know the total time, it is a series of n add operation, and this is proportional to this one, n plus c plus 2c plus 3c plus 4c and so on. Okay, so if I have the, for example, c equals to 1, then whenever I have the n elements, so when I add one more, then I will add 1. Okay, if I have another element, then it means I will add 2 multiplied by 1. Okay, and then if I have another element, then I will add 3 multiplied by 1. Okay, and so on. So this is a series of operation until k. Okay, so k means the number of n. Okay, if it is 3 equals to 1, then we will have another n. Okay, so the c can be extracted, and then I have the 1 plus 2 plus 3 plus and etc. until k. So we can have the n, it will be added by k plus multiplied by k plus 1 divided by 2. Okay, how can you get this one? Okay, this is the result of this one. Okay, if you know the arithmetics, okay, this will be the result. It's the same with this one. So maybe you can just like, for example, 1 plus 2 plus 3. Okay, so it means the same with the 3 multiply by 3 plus 1 and then divided by 2. Okay, so what is it? The result will be 6, and this result will be also 6. Okay, so by using this arithmetic operation, then you can see that, yeah, we have n plus we have the k multiplied by k plus 1 divided by 2. So if I change k into n, what happened? Then it will be the same like n multiplied by n plus 1 divided by 2. Am I right? Okay. So we maybe if I change to k, okay, n plus k power of 2, okay, because here k multiplied by k, this will be k power of 2. Okay, and because I just let the small degree, just remove the small degree, so I can have the big O is O n power of 2. And in order to find the amortized time of an add operation, then it is O n. How can we get this O n? Okay, because we can do the Tn divided by n. So what is Tn? Tn is the big O with the quadratic function. And then I want to divide with n. Then the result will be O n. Okay. Okay, then if you are dealing with the doubling strategy, it means once you finish with the first addition, okay, once you finish the first, so the next will be double. The next will be double from the previous, so it is 4. The next will be double from the previous, which is 8, and so on. So the number of the elements will be 2 power of k. Okay, and let's make the k equals to log base 2 n times. Okay, so using this one, yeah, we can say this is like the, so you can have the logarithm. Okay, so you as I mentioned to you in the algorithm analysis, you can review again about this logarithm function. Okay, so if you have this series, then you will just make this one. Okay, 2 power of k plus 1 minus 1. Then I can get with the definition of this k equals to log 2n. Yeah, so I can just replace this one 2. Okay, this is the basis 2, and then I have the log 2 n plus 1, yeah, and we have minus 1. Okay, so if you have this function, okay, you will get this is the n plus 2n. Okay, so yeah, just understand this one more. Okay, and then we can get this one as 2n, and we have the n plus 2n minus 1. Then the result will be this one, 3n minus 1. Okay, and we have the 3n minus 1, as you know, for the big O analysis, the Tn will be On. And when we are dealing with the amortized time, so we can do the Tn divided by n. Okay, and we know the Tn is On. The On, if you divide it with n, then the result will be 1. Okay, so the result is O1. And we can say with the doubling strategy, you will have O1 or constant time. So this is the dynamic array in Python implementation. You can check on the Python. Okay, so um, this is this array. Okay, oh yeah, I would like to show you this array with primes. Okay, and then now in this list you can use the append. Append means you want to add. Before you have the red, blue, and green. If I want to append yellow, what happens? So the new data will be added: red, blue, green, yellow. If you want to remove, for example, you want to remove one object. So in this case, you cannot remove the index. Actually, you can, but yeah, let me just show you how to remove the object. So remove blue, and then yeah, blue will be deleted. And if you want to insert, yeah, so insert means yeah, the same with the word that we learned before. I want to insert in index 1, and the object is white. So you can have white, and the value will be added here. Now, this kind of a list you can represent it with the dynamic array. So this is the dynamic array. So you can have the C types is just the data type. Okay, and when you are making the dynamic array, yeah, this is the method or the class for the list. Okay, you can initialize. And then the first is the capacity equals to 1, and then you can make the array, and the length, yeah, you know, length is the length or the size, and then get items means you want to get the particular atom in the specific index k. Okay, and using this one, then you will check the index. If the index is less than k or the index is greater than n, then it is invalid. Also, you want to return with the particular index. You can have append, you can resize, you can make array, you can insert, you can remove. So those methods are created for this dynamic array, and the function is same with the with, with this list. Okay, so this list also is applicable with this dynamic array. Okay, I guess that's the thing. Yeah. So oh, I don't know why I have this one. Maybe I don't need this one. Okay. So the things you learn from this chapter is about the array-based sequences and then the types of operation and the global array. So I hope that you understand the concept of array, because it's not that difficult now. You already know from the computer programming, and the idea of the array is not that complicated. But the idea to grow the array is, yeah, they have some strategy. It depends on your strategy. And of course, the Python and Java or other computer programming languages, they will use this kind of strategy to minimize the time complexity. Okay, so thank you very much for listening the video. I will do the next lecture with the real time using WebEx. So make sure that you turn on the WebEx, and yeah, we will learn with the WebEx in the other chapter. Okay. So thank you for listening. See you on the real time class.